All right, in section 7.2, we're going to learn about angle, side angle, and angle, angle, side. So the angle, side angle postulate basically just is another way to prove that triangles are congruent. And let's say I have two triangles, triangle ABC and triangle FDE, and they're marked like this. Remember that those little arches represent angles being congruent. So looking at that, angle A and angle F I would know would match up, and angle B and angle D would match up. Also, that tick mark on the middle of the segment indicates segments that match up, so I know that AB and FD are congruent segments. Using this information, that's all that I need to see to know that triangle ABC is congruent to FDE, and I would prove those congruent by the angle, side angle theorem. What's important to know about this theorem is that the side is like sandwiched between the two angles. Another way to look at it, that side kind of connects the two angles together. Let's look at a proof using angle, side angle theorem. So let's say I have this diagram here, and I want to prove that triangle ABC is congruent to triangle AED. So looking at that, my given information here is that angle CAB and angle DAE are congruent, because I see that little arch tick mark there. I'm also given that side length BA is congruent to EA. And finally, I'm given that angle B and angle E are both right angles. So knowing what we know about right angles, they all equal 90 degrees, so I can conclude that angle B is congruent to angle E. My reasoning there, definition of right angles, another way I could say that is all right angles are congruent. Either one of those works as a reason. Now, I could even kind of change the marking a little bit to match up to that diagram that we had before. I have an angle, side, and an angle. See there again, that side is sandwiched between the two angles, so I can say that triangle ABC is congruent to triangle AED by angle, side angle. Last thing we're going to learn about today is the angle, angle, side theorem. Now, this is going to look really similar to the last one that you just learned, but just the order is kind of different here. So notice that now the S isn't sandwiched in the middle. This would look something like this. So let's say my triangles are marked up this way. I have two angles marked congruent and a side. The only difference here is that notice that that side isn't sandwiched in the middle anymore. That's really the only difference. So let's look at one more proof and then we'll be done. So I want to prove that triangle WMR is congruent to triangle RKW. And it looks like my givens here are that WM is parallel to RK. Remember, that's what those little arrows represent. And finally, I'm given that angle M is congruent to angle K. So looking at that information, the parallel lines are going to help me create an angle pair here. So these are my parallel lines. I could look at WR as a transversal. I'm able to say that angle MWR is congruent to angle KRW because they're alternate interior angles. So now I have two angles marked congruent. Finally, I can see that both of these triangles share side length WR. So now that's where that reflexive property comes in. I could say that WR is congruent to WR, congruent to itself, by the reflexive property. Now I have two angles marked congruent and a side, but notice here I have an angle, and the side's kind of on the outside of it. It's not sandwiched in between anymore. So I would say that triangle WMR is congruent to triangle RKW by angle, angle, side.